How can we solve this? Where we have x squared equals -4. Some of you are maybe frightened looking at this problem. Together we will solve this problem. Hi, my name is Patrick. Welcome to my YouTube channel, Better Math. What times what equals -4? We will find solutions and we'll check our answer. Let us continue. So if you think you can solve this problem, go ahead and pause this video and try to solve this on your own. Now let us begin. Let us begin this example if we're given the square root of 4. Look at the answer of 2, which is the principal square root. If we're given a quadratic equation of x squared, where we'll get an answer that is the principal square root and another answer that is not the principal square root. There will be more than one solution with this quadratic equation. Using a scientific calculator, we can enter 4, then press the square root button, and finally press the equal button to get the answer of 2. That is the principal square root. Again, if we try our scientific calculator, we press the 4 button. Now we press the plus minus button. Next we press the square root button, and finally press the equal button. We'll get undefined as our answer. Maybe your scientific calculator will show error, or something else. If there are some fancy, expensive math graphing calculators that will show the correct answer, which we'll soon get to. Most calculators out there are dealing with real numbers only and do not understand those numbers that we'll discuss soon to get to solutions. Also, some of these fancy math calculators will show there are 2 answers for the quadratic equation. This fundamental theorem of algebra states that at every polynomial of degree n, which is n greater than or equal to 1, has exactly n roots, counting multiplicity. Those roots can be real or complex numbers, and a complex root always appears in a pair of complex conjugates. In most cases, this is true. Sometimes it can be less than the number of roots. This is a theorem is telling us that there should be 2 solutions to our equation x squared equals -4, which there will be. Let us do an example of a second-degree equation or a quadratic equation that has 1 solution. We begin with x squared minus 2x plus 1 equals 0. Yes, this quadratic equation, which can be simplified to x minus 1, all that squared, equal to 0. And we can write this as x minus 1 times x minus 1 equals 0. Here we have the equation equal to 0, so we can use the zero product property, where something on the left side of the equation equals 0 to match the right. After we simplify, we'll have x minus 1 equals 0. Next, we can add 1 on both sides of the equation. This will keep the equation balanced. If we want to do the one side of the equation and keep it balanced, we have to do the other, like a teeter-totter. On the left side of the equation, we can change minus 1 to plus -1, which can help us in the simplification. Now, on the left side of the equation, we have minus 1 plus 1 equals 0. And we will have just x on the left side of the equation. On the right side of the equation, we have 0 plus 1 equals 1. This will finally get us the answer of x equals 1. Checking the answer of x squared minus 2x plus 1 equals 0, where x equals 1, substituting 1 into the equation for the variables of x, we'll get the following. Using PEMDAS to help us memorize this saying, we can use, please excuse my dear Aunt Sally. We'll do the exponent first, where 1 squared equals 1. Again, using PEMDAS, the order operations, which will do multiplication, where we have -2 times 1 equals -2. Now we'll do 1 minus 2 equals -1. Next, we will do -1 plus 1 equals 0 to get our answer of 0 equals 0. Yes, 1 is the solution to this equation. Now let us look at another example with a quadratic equation of x squared equals 4. If we have the square root on both sides of the equation to keep the equation to be balanced like a teeter-totter. And on the right side of the equation, there can be a positive and negative answer of plus or negative on the square root of 4. Taking the square root of 4 will give us the answer of positive and negative 2, where x of 1 equals 2 and x of 2 equals negative 2. Now we check our answer where x equals positive 2 with the original equation of x squared equals 4, substituting x with 2 to give us the following: 2 squared equals 4, which we can write as 2 times 2 equals 4. Finally, we will see that 4 equals 4, which proves that x equals 2 is the solution to the equation. Next up, we check our answer with x equals to negative 2 with the equation of x squared equals 4. First, we substitute negative 2 into x to give us negative 2 in parentheses squared equals 4. We put the negative 2 in parentheses to avoid problems, where negative 2 squared equals negative 4 because the number is going up by the exponent but not the sign. And this can be broken down out to be negative 2 in parentheses times negative 2 in parentheses equals 4. Using the commutative property of multiplication, where AB equals BA, we can change this to negative 1 times negative 1 times 2 times 2, all that was in the parentheses, equals 4. We see that negative 1 times negative 1 equals 1. When we are multiplying two negative numbers together, their product will become a positive number. Finally, we will have 2 times 2 equals 4. That proves 4 equals 4. And making this x equal negative 2 to be the other solution to this equation. So we found that x equals plus or minus 2 as a solution to the equation of x squared equals 4. This gives us x sub 1 equals 2 and x sub 2 equals negative 2. Some of you may be going, hey, big guy, big fry, I thought we were trying to solve for x squared equals negative 4. And why are we doing all these crazy stuff and not the equation? Well, I'm just trying to help people understand on what to do these quadratic equation examples. Back to the original problem where we have x squared equals negative 4. And we will have two solutions to this quadratic equation from the principal theorem of algebra. First, we will take the square root on both sides of the equation. On the left side of the equation, the square root will be the same as taking it to the power of 1/2. And we will have x squared to the power of 1/2 equals the square root of negative 4. Now the exponent or power will be 2 times 1/2 equals 1 using the power of a power rule. And then we'll have x equals plus or minus the square root of negative 4. I hope that you're learning from this video. So if you're learning from this YouTube video, please like and subscribe so that I can reach out to other people and help them just like I'm helping you with my channel. And I appreciate your support. Enough of this commercial break, and thank you for that. And let us go on to solve this equation. From the original equation where we have x squared equals negative 4, we have x equals plus or minus the square root of negative 4. Or that we can write the equation as x times x equals negative 4. Some of you may know for the numbers of 1, 2, 3, 4, 5, and so on. And they all have a perfect square for those numbers, which are 1, 4, 9, 16, 25, and so on. 4 is the perfect square for the number 2. Hopefully many of you have noticed that. If we try 2 times 2 equals 4, that does not equal negative 4. If we try negative 2 times negative 2, which will equal 4, and that's still not equal to negative 4 as well. As we have here that x squared equals negative 4, what will work for our solutions? We will get the following: x equals plus or minus the square root of negative 4. Now we can break this down where negative 4 is equal to 4 times negative 1. Using the radical product rule, we will get that the square root of 4 times negative 1 equals the square root of 4 times the square root of negative 1. We can use that the square root of 4 is 2, and this will leave us with x equals plus or minus 2 times the square root of negative 1. Another way to think of this is where what squared is negative 1, or x times x equals negative 1, which is x squared equals negative 1. We'll find the square root of negative 1 is I, where I is an imaginary number, while I squared equals negative 1. Some people are saying it is an imaginary number. What is that? Some people are saying I can imagine a lot of, and I'm not imagining imaginary numbers to be the value of the square root of negative 1. Some people are saying the imaginary numbers are not my imaginary friend. Imaginary numbers were discovered in the 15th century. Later, they were first given as a derogatory term in the 17th century. At this time, mathematicians were debating about these curious numbers. Later, it was found to be very useful, but the imaginary number name stuck. And later, complex numbers were added, which were expanded upon imaginary numbers, where complex numbers have a real number unit and an imaginary number unit, such as this. I remember when I was learning imaginary numbers in my algebra class in college, it was interesting to learn what happens when I took the square root of negative 4. I know that some lower math, it would be considered to be an undefined with this equation or an error or something. In algebra, I learned that this is not undefined and there are some solutions to the x squared equals negative 4, where imaginary numbers are used in mathematics, science, engineering, and so forth. So let us continue. So the solution that we have found is x equals plus or minus 2 times the square root of negative 1. And this can be simplified to be x equals plus or minus 2i with the imaginary number, where x sub 1 equals 2i and x sub 2 equals negative 2i. First, let us check where x equals 2i. Well, the equation of x squared equals negative 4. We'll begin by substituting 2i into the variable x. Now we have 2i squared equals negative 4. We can revisit it as 2i times 2i equals negative 4. Using the commutative property of multiplication where ab equals ba, so we can arrange the numbers as above. So 2 times I equals negative 4, where 2 times 2 equals 4, and I times I equals I squared, or negative 1, as we're multiplying the imaginary numbers. Now, when we do 4 times negative 1 equals negative 4, prove that negative 4 equals negative 4. Now let's check our answer with x equals negative 2i for the equation of x squared equals negative 4. We'll begin to substitute negative 2i into the variable x. Next, we will have negative 2i squared equals negative 4, which can be represented as negative 2i times negative 2i equals negative 4, using the commutative property of multiplication where ab equals ba, so we can arrange the numbers as above. This will give us negative 2 times I times I. Here the two negative numbers will cancel each other out, making a positive number when we do negative 2 times negative 2 equals 4. And we will have I times I equals I squared equals negative 1 when we do the imaginary number multiplication. Next, when we do 4 times negative 1 equals negative 4. Finally, that proves negative 4 equals negative 4 for the second solution. So we have found the answers to the equation and proven that x sub 1 equals 2i, x sub 2 equals negative 2i as solutions to the equation of x squared equals negative 4. Hope that you learned something from this video. Please like and subscribe to my YouTube channel, and thank you for watching, and have a nice day.